All right, so we're going to step away a little bit from the composition work that we've been doing. It'll come back for us in a couple of sections, but what we're going to do is introduce ourselves to a couple of new functions, particularly one in particular. Keep in mind what we have is this idea of a base function, right? So going back through time, some of our basic ones are f of x equals k, right? So a nice constant function. F of x equals x, so that's our most simplest line form. Our most simplest quadratic, x squared. We know what an x cubed looks like. X squared, cube root of x, 1 over x, absolute value of x, right? So we have a pretty solid foundation of base functions, and with those base functions we can do a lot. We can solve equations with them, we can do some quick graphing with them as we transform them, move them left or right, move them up or down, stretch them, shrink them, whatever the case might be. So that's where we're heading in 6.3. We're going to be taking a look at a new function. It is called the exponential function, and it turns out that there's two types. There's growth models and there's decay models, right? So let me go ahead and get to the definition, and then we'll start getting a feel like we did with all these other guys, right? What their graphs look like, what their behaviors seem like, what their domains and ranges are, some of their characteristics. So our new function, an exponential growth function, right, is a function of the form f of x equals a to the x, where our a is greater than 1, right? And that's basically it. How is this function different from the previous functions that we've studied, everything that I have up here? And usually I let students kind of struggle with that until someone pops up the answer, but we're online and I'm on video, so I'll just cut to the chase. What's different is look at where the input's at, right? In all these cases, the input is usually the base, right? Even here, this is x to the 1/3 power, or x to the 1/2 power, or x to the -1 power. So usually the variable that we're using to be is the input variable. The domain value is usually a base value. But here what's happening is the input is actually in the exponent. So it's actually the base that's staying the same. It's some value, a is greater than 1, so maybe it's 1.2, or it's 2, or it's 3, or it's 4, it's 5, 10. It could be anything we want. But what we're doing is we're going to take a look at what happens when the exponent changes and goes on and on and on. Right? So that's how it's different. And of course, because of that difference, it's going to have some different behaviors, some characteristics that we're going to be able to study and learn from and apply. Right? So let's get into that. Let's go ahead and do a little bit of investigation. What does what does an exponential growth function look like? Well, let's start off with a real basic one. We have 2 to the x power. And what we normally do, right, to get a graph is we start point plotting when we're learning something new. It's always nice to try a couple of negatives and to try 0, right, get our y-intercept, and try a couple of positives, right, at a bare minimum. So when I put 2 to the -2, right, what that becomes is 1 over 2 squared, what we know to be 1/4. So we get a value, an output of 1/4. 2 to the -1 becomes 1/2. When I put a 0 in there, 2 to the 0 is 1, right? Anything to the 0 power is 1. 2 to the first is 2, and 2 squared is 4. So there is some data that we have to look at. So plotting the data, we got a y-intercept at 0, 1. We've got 1, 2 as a data point, 2, 4 as a data point, and then -1/2, and then -1 1/4, right? And so there's basically our graph. And if you don't think we have enough information to see what's going on, it looks like what's happening is we go bigger and bigger and bigger along the positive x-axis. It looks like our function is starting to simply explode, right? Exponential growth is what we call that. As opposed to if we get bigger in the negative direction, what happens is our fraction is getting smaller and smaller and smaller. To see that, let's go ahead and do a couple more values. If I put a -3 in there, 2 to the -3 becomes 1/8. So that's even smaller than 1/4, right? And if we put a 3 in there, 2 to the 3rd is 2 times 2 times 2, which gives us 8. So 3 gives us an 8 value. So we definitely see, starting from this y-intercept, as we move in this direction, as x gets bigger and bigger and bigger positively, the function really just starts to explode, as opposed to in this direction is we go to negative infinity, we're just going to keep getting fractions that are smaller and smaller. So 1/8, 1/16, 1/32, right, 1/64. So they're not 0, but they're very tiny numbers. And that is what the graph of f of x equals 2 to the x is going to look like, right? So let's see what the next one looks like and see if we can establish any patterns like we did with x squared and x cubed and all that other stuff. So the next one, well, again, I'm going to do these in my head if that's okay. If I put a -2 in there, right, 3 to the -2 becomes 1/9. And 3 to the -1 is 1/3. 3 to the 0 is 1. 3 to the first is 3. And 3 squared is 9. So the intercept hasn't changed, right? We're still at 0, 1, just like the last one. 1 is now 3. 2 is now 9. Right, and then we're a third and a ninth and whatnot. And so we see that again, in the positive x direction, our graph is exploding, maybe even faster than this one, right? And then over here, right, it's getting closer and closer to 0. So the numbers are different, right? They're definitely different. We have 1 and 2, 1 and 3, 2 and 4, 2 and 9. But the overall behavior is exactly the same. In the positive x direction, the graph is starting to explode, again, exponential growth. And in the negative direction, the graph is behaving like it has a horizontal asymptote, right? It's just being the x-axis, because it's just getting smaller and smaller and smaller as we go in that direction. All right, so there's that. So what do you expect about the graph of y equals 4 to the x, right? Do you have any, do you anticipate anything happening, right? And if you're thinking it's going to look like this, you're right. The data points are going to be different, but the general shape is going to be the same. So let's just plot some points. 4 to the -2, well, that would be 1/16, right? 1 over 4 squared. 4 to the -1, that's going to be 1/4. 4 to the 0, there's our 1 again, right? Because anything to the 0 power is 1. 4 to the first power is 4, and 4 squared is 16. So you can see it's getting really big, really fast. So we have 0, 1, we have 1, 4, 2/16 is way off the charts, right? -1 gives us about 1/4, -2 gives us about 1/16. So again, in this negative x direction, we start getting closer and closer and closer to the x-axis, and in the positive x direction, the graph just explodes, even faster than 2x and faster than 3x. So it's getting big very, very fast. So again, the data points, the exact data points are a little different, but the overall behavior is very similar. In the negative x direction, we're behaving like a horizontal asymptote. In the positive x direction, it's exploding very fast, and they all, right, are one point that they do all have in common is the y-intercept of 0, 1. All right, and then last but not least, here, let me throw a fraction at you. All right, so we have 3/2 to the x power. Right, what are we expecting out of this? Well, again, if you're kind of paying attention, I expect the graph to kind of look like this. So if we do 3/2 to the -2, right, that's going to basically give us a reciprocal. That's 2/3 squared, which is 4/9. If we do 3/2 to the -1, again, that's just a reciprocal. That's 2/3. 3/2 to the 0 power is 1. 3/2 to the first power is 3/2. And 3/2 to the second power is 9/4. So if we plot this data, again, you can see the point that's common is the y-intercept of 0, 1. That seems to be a very common point. It is a common point. When we're 1, we're 3/2, so 1.5. And when we're 2, we're 9/4, which is basically 2, what was that, 4, 2 1/4. So right in there. And then in this direction, we're 2/3. Right, and then we're 4/9, and on and on. So we're still in this direction, eventually going to 0, and in this direction we're still climbing up, but definitely not as fast as the other one, right? Because our fraction isn't quite, it's getting closer and closer to 1, but it's still going up. Even if we had put 3 in there, right? 3/2 to the third power would it give us 27 over 8? And 8 goes into 27 3 times, and almost 4, right? And so at 3, right, we're almost 4, so right about in there. So so the graph it's not growing as fast as these two, but it is in the x direction. The graph's eventually going to explode towards positive infinity, where in the negative x direction we have basically a horizontal asymptote. All right, so those are some attributes that we can see. I'm 10 minutes into this, so how about we see the patterns and do some basic behavior so we can get some basic knowledge of a graph. But I'll do that in the next video now that we've actually seen some of this stuff in action. See you guys shortly.